Good morning, Algebra 2 Trigonometry students. So today I would like to talk about the lesson day 13. So evaluating inverse trig functions. And this one, so yesterday we talked about the inverses. So this one is just on top of that. So it's just like a more exercise regarding the way to find out the measure of the angle with the inverse of trig ratios. So let's take a look at that, the first one. So this one is given as a parallelogram. It looks like a parallelogram here. And we do have the right triangle. So one is going this way, the other one is upside down. So we do know that this angle here, it's theta. So it's connected with the 90 degree and part of the angle here. So the whole thing here is considered theta. So let's give another name for this base angle. So let's say this one is theta prime. So in order to get that theta prime, so we want to use that the trig ratios. So the one that's given here, it's considered adjacent, and the one over here, that's considered hypotenuse. Again, adjacent is always the side length right next to the base angle. So adjacent, hypotenuse, so that means we're using the ratios of cosine of theta prime. So that equals 5 root 2 over 10, because that's considered adjacent over hypotenuse. And then once you reduce, so this one is considered root 2 over 2. And one thing that we notice, inverse of root 2 over 2. And this one is considered 45 degrees. So theta prime is 45 degrees. And then 45 plus 90. And then you'll get theta. So which is considered 135 degrees. So this one's pretty basic. And here's another one. Carpentry. So you're making a door stopper from a block of wood, and when the door rests against the stopper, and you want a corner of the stopper to extend through the width of the door. If the bottom of the 1.7 inches wide door, it's 0.7 inch off the ground. Okay, right here at the diagram. And what is the angle of theta of the door stopper? Okay, so one thing that we notice, if two line segments are parallel, so that means the alternate interior angle got to be exactly the same. So this two angle right here, they consider alternate interior angle. So this one is also considered theta. And one thing that we notice about the width here, it's 1.7 inches. And this one is 0.7. So that means we're using it as adjacent, opposite. So in order to get tangent, in order to get theta, so we're using the ratios of tangent. Tangent of theta. So it's opposite over adjacent, so it's 0.7 over 1.7. And then what we notice here, it's considered 7 over 17. So tangent of theta is 7 over 17. In order to get the value of theta, so we put it into the calculator, inverse of tangent of 7 over 17. It's a non-special ratio, so that's why we have to use a calculator for this. So degree, inverse of tangent of 7 over 17. So that's about 22.38 degrees. So 22.38, so just round it up to one decimal place, so 22.4 degrees. Okay, so 22.4 degrees. Okay, so now for C, the flight. A falcon perched at a height of 100 feet descends straight toward a prey that is 125 feet away. And at what angle does it descend? If the falcon ascend along the same path as it descended, at what angle does that ascend? Okay, so the falcon, so the height, it's 100 feet off the ground, and going straight toward a prey, and that's 125 feet away. 125 feet away. And what angle does that descend? So we're looking for this angle here. Okay, so theta. And then if the falcon ascend along the same path as it descend, at what angle does he ascend? So we're looking for the other angle. So let's say this one, it's theta prime. Okay, so start finding theta. So this one, we do know that it's adjacent. And this one is the hypotenuse. So for theta as a base angle here. So that means we're using the ratios of cosine of theta. So that equals 100 over 125. And then we take the inverse of this ratio. So 100 over 125, so divided by 25 top and the bottom. So we got 4 over 5. So inverse of cosine of 4/5. Okay, so let's find out what that is. And this one, it doesn't tell you how many decimal places you want to round. So normally we try to round it with either one decimal place or round it up to a whole degree, the whole unit with the integer. So inverse of cosine of 4/5. Okay, so inverse of cosine of 4/5. 4 over 5. And it's about 37 degrees. Okay, so 37 degrees. And then in order to get that theta prime, so we can do it either way. We can just subtract this angle from 180 minus 90. We can subtract that from 90 to get that theta prime. So 90 minus 37. It's easier to do it that way. So which is 53 degrees. Another way you can do it, you can use sine. So for theta prime, so this one turns out to be the opposite. So sine of theta prime. So that's considered 100 over 125. So in other words, inverse of sine of 4/5. So that equals theta prime. Okay, so now let's find out what that is. So that's just a different approach. So inverse of sine or 4/5. So it's about 53 degrees. And which is the same as the one that we found with that triangle sum theorem. So again, this one is just like the basic examples regarding the way to solve for the right triangles. So I'm going to put up another video lessons regarding the way to solve for the right triangle. So that one's going to be a little bit more complicated. So make sure that you watch it after you finish watching this one. So I'm going to put it on the end screen there on YouTube, and you guys will see that. So thank you for watching it. So if you do like the video, I would like to subscribe that and make sure that you click the bell. Alright guys, have a great one, and I'll see you guys next time.